All right, so just to talk a little bit about what I'm going to talk about here is I'm going to actually focus on all of the stuff from the back end in terms of building out an analytics pipeline and talk about the different kind of approaches you can use from starting simple. I try to do that in my talks. I try to say, hey, here's a simple, low-hanging fruit, and then you can kind of build on it. So I'm going to take the same approach here. I'm not going to cover anything related to the actual, like what you would do, like integration into the game, because actually the talk immediately after mine by John and Mike, they're going to cover that. And they're going to talk about our analytics SDK and how you can integrate it into your game. So that's coming. So just keep in mind that how to actually get your data into AWS will be answered in about an hour. So when we talk about mobile games, and console games as well, like what is the actual landscape looking like? It's very different now than it was 3 or 4 years ago. Free-to-play has become the dominant means of actually publishing your game, and it's all funded by in-app purchases. There's exceptions to this. Obviously, we can think of games where they're $2.99, and there's a few handful of developers that say, hey, one time $2.99, that's all you have to pay, et cetera. But that's a minority. Most of the market continues to move to free-to-play. And there's a few reasons for that. First of all, the fact that it just gets you a broader customer base. It's easy. You don't have to convince somebody to just download something for free and at least give it a try. The second reason is it doesn't put a cap on the amount of money you can earn from a user. If you charge somebody 99 cents, then no matter how long they play, that 99 cents is all the revenue you're ever going to get, even if they just love your game and thinks it's the best game ever. So free-to-play with in-app purchases really allows you to capitalize on that. And it's all about the long tail. And that's obviously keeping people on your game, keeping them interested. And cross-platform is another aspect of that, starting out on iOS, being able to go to Android, or vice versa. Going global, as we touched on, not only from an infrastructure perspective, but also getting your actual game pushed out to different regions. And it all boils down to user retention is revenue. If you have somebody on your game for 6 months, they're going to make you more money than 3 months, more money than 2 weeks. You get the point. So this is one of those, again, crystal ball slides that Gartner has. But it's actually, I think, they're not the only ones saying this. So it's actually pretty interesting data, I think. And what they're seeing is that if the trend continues, is that actual purchased apps are going to kind of just level off and just kind of stay where they're at. And the majority of revenue is going to continue coming from in-app purchases. And that's what the blue line is. The yellow line is the actual amount you pay up front. And then the blue is in-app purchases. And the little green part is ads. Obviously, ads continue to become more and more of a factor. My personal take, I'm not sure about the last little green line, because there's some point in which ads are just so overbearingly annoying that then they cause actual user abandonment. So I think there's going to be some kind of balancing there that happens over the couple of years. But regardless of specifics, this is what we're seeing pretty consistently. So how do you actually succeed? And like all great business plans, phase 1, collect data. Phase 2, analyze. Phase 3, profit. And so there's a few more steps to that, right? But that's actually kind of the gist of it, right? But what are we trying to analyze then? Like, how are we actually trying to figure out whether or not people like our game or not? What you're actually trying to do is you're trying to get at their emotional state, right? You're trying to understand, like, are they enjoying the game? Right? Are they engaged? Are they really, is the experience really enriching to them? New content you release, are they liking it? Are they actually, they like the direction the game's going, or do they not? Or is it turning them off? And then kind of on the negative side, are they stuck on a level? Are they there and they just can't get any further along? Are they getting bored with the game? And then finally, are they just giving up and move on to the next game, which is obviously what you want to avoid. Now, the tricky thing with this, as you all know, is that there's no way you can directly actually measure an emotional state. Even if you ask a person, and there's been some really interesting psychology studies on these, even if you ask a person what their actual state is, like, hey, do you like this game? Their responses have absolutely nothing to do with reality. It's really fascinating. It really is. What actually happens, not to write off on a tangent, but what actually happens is when you ask people in social situations about their interests, et cetera, they actually slip into these kind of social norm states. You say, oh, well, what kind of person would you like to date? And you say, oh, well, I'd like somebody that's caring, and I'd like somebody that's kind, and has a good sense of humor, et cetera, right? But the reason why the dating sites are making a whole lot of money is they actually don't listen to people at all. What they do is they instead monitor their behaviors, right? They say, okay, well, based on who you've actually dated and how it's worked out, why don't you try this kind of person, which might have nothing to do with the actual person that they say they'd like. So in terms of measuring behaviors, if it's not specific, if it's not measurable, then it doesn't matter. So there's simple stuff, low-hanging fruit, like how many hours are they playing a day or a week? How many times are they playing? How many individual sessions? Are they playing 5 times a day? Are they playing 1 time a day? Are they taking every break that they can in order to slip in a game? How are they progressing through the game? Level both being on an individual perspective, like how are they leveling up, but also how are they making it through the game? How quickly are they making it through different levels? Are they having to spend a day at a time, or are they knocking out levels one after the other? Friend invites and referrals is another good way. With all these, and these last couple of ones, I want to kind of point out something. Responses to mobile push, and then money spent a week. Responses to mobile push is actually pretty good because you're sending a push notification, and that tells you whether or not you've got a good push notification. And again, John and Mike, after my session, will talk more about push notifications, how to measure that, how to find out if you're doing effective targeting. But the friend invites and the money spent a week, I want to just add a point of caution. It's not enough just to measure those, and there's a couple of reasons why it's not enough to just measure those. First of all, if you offer any kind of incentive for friend invites, like, hey, invite a friend and get 50 bonus points or whatever, then that is a totally bogus metric, right? Because you're driving people, you get what you measure. You're driving people to actually do friend invites. So whether or not they're actually doing it, all that tells you is whether or not they want 50 bonus points. It doesn't tell you whether or not, on their own accord, whether or not they think your game is interesting. And then it's the same way with money spent. It might seem like a great indicator if somebody spends $10 on your app, and it's a good piece of data. It is. You should definitely make use of it. But they could be spending $10 on your app because they're just getting frustrated and they're stuck, and they say, oh, well, I'll try a couple power-ups. It didn't help at all. I'm over it, and then they abandon your game. So it could actually tell you the exact opposite emotion of what they're actually going through. You would say, oh, wow, they're spending a lot of money. They love my game. No, they're spending a lot of money because they're frustrated with your game, and they're about to give up, and then they give up. So let's look at some real trivial examples here. And I want to use this to highlight kind of different kinds of data you're going to want to collect. This is a simple example with level progression. This is the number of tries per level. I just made this data up. This is totally bogus data. But it's just to actually illustrate a point, right? The idea being is, hey, for level 1, 2, 3, 4, 5, this is how many tries it took in order for a person to get past this. So you collect this data, and it looks like level 7 is really too hard, OK? And so first off, the thing I want to highlight, this is already way better than having nothing. Right? So when it comes to collecting data, one thing I'll talk about as we go through this is that just collect anything you can. Like, something is better than nothing. If you're flying blind, then you just have no idea what's going on with your game. You can only guess, maybe based on the reviews people leave on the App Store. So at least collect something. And we'll go over what you can do to collect that low-hanging fruit. This at least gives us some indication that there might be something with level 7, but there's not enough data for us to actually draw a conclusion out of this. The reason why there's not enough data is because level 7 could be a boss level, right? Or it could just be a level where intentionally you threw them a curveball, and then what actually happens is at level 8, the reason why that one's so easy is they've become a better player. They've honed their skills on level 7, and now when they get to level 8, which is actually just as difficult if you were to kind of measure it mathematically, they can whip right past it because they actually have those newly acquired skills. So you need more data. So what, again, this is totally bogus, right? But you get the point. So this would be an example of a secondary data set you could actually track. And that would be what, out of your user population, what percentage is a given level, like the last level they play? What percentage is the highest level? So when we look at this in the blue bar, wherever that's a jump, that says, hey, that's a user abandonment point. A lot of people play that level, and then they never go any further. So it does kind of bear out our suspicions that level 7 is too hard, because a whole lot of people get to level 7, they just give up. That's the last level they play. But the interesting thing about this data, again, totally bogus, made up, but stuff like this happens, is that level 4 looks like a whole bunch of people give up on level 4 too. But it doesn't really look to be like a difficulty thing, because the difficulty seems OK. In fact, difficulty is a little easier than level 3. So what else is going on? Maybe they're just getting some more of the same at that point. Maybe there's something specifically in that game that turns them off. Maybe you introduce a new kind of monster or a new challenge or something, and people just don't like it. There's interesting social norms you can find out. Colors, in different parts of the world, different kinds of colors, different kind of personages can actually turn people off culturally. So the point of this being is that the more data you collect, first off, this gives you a lot of great insights. So already you're way ahead of not having anything. So this is great. You can go back and you can at very least tune level 7 right away, make it simpler, provide an update, and smooth that curve out. And then it gives you time to dig into level 4 more And that's what I want to highlight as well, is it creates this virtuous circle where the more data you collect, the more you're going to be able to improve your app, the more questions you're going to ask, and then you're going to collect additional data. And the more you do this, and the more you get in the habit of doing this, then the easier it is to spot these trends, and the easier it is to make meaningful changes in the game. So key points about this introduction is you need multiple data sources. It's not enough just to collect 1 or 2 metrics. You need to collect a good cross-section. We'll talk about some examples. Correlate these different variables together. And what you want to do is you'll want to index them based on user stuff. I have some examples. But you're going to basically take a couple different sources of variables, correlate them together. And usually it's the case that deltas versus absolutes are more interesting. Like, what's the percent change over time? Is this level X% harder than this one? Rather than just saying, oh, well, this one's 20 and this one's 25. Well, what does that mean, right? Usually percents, are more interesting. And then when you're figuring out your analytics strategy, just kind of figure out a terminology. It's important to keep your sanity as you keep collecting more and more data. There's no one right answer, but just kind of settle on what you're going to call a game. Is that your whole thing, or is that like a section of the game? What are you going to call a level, right? Again, is that a level or is that a checkpoint? Just kind of decide, hey, here's what we're going to call these pieces. And the last point I'll make is that time matters. It is a key metric that you want to always put along with your data, and I'll talk about that in just 1 or 2 slides, is that you want to make sure you know whether or not a person is progressing over a 3-day or a 3-week or a 3-month period, because that tells you very different things about your game. So the actual data that I showed you is, again, it's better than having nothing, but there's no time component, which is a key part. Like, we don't, like, how long did that, when we were talking about a person going from level 1 to level 10, like, was that a day? Was that 10 weeks? Like, we have no idea, right? So you want to track time. It's very important. Excuse me for a sec. So Robio is recently released a case study on AWS. Huge user of AWS. And if you read their case study, they talk about some of the stuff they use, like our Elastic MapReduce product, for doing data analytics. What I want to highlight is companies like Rovio with Angry Birds, companies like Supercell, they're not getting lucky. There's a certain amount of luck that's great, timing or good game design, but that's not really luck. But they absolutely have their games instrumented, and they know exactly what their players are interested in. They know exactly what their players are doing, and they have it very, very finely tuned. So what are some of the strategies that these guys use? So I want to, again, on the terminology thing, I want to actually spell out a little bit of terminology. First off, so event is a moment in time, right? An event is what's happening right now. And an event is typically correlated with some kind of game event. They're logging in, they're starting a game, they're quitting a game, they made a purchase, et cetera. And then a metric is what you're actually measuring. The point here is just keep it simple. If you can just keep it to numbers, floating point numbers, integers, et cetera, you'll be in really good shape. Just say, hey, this happened and the value is this. And if you can keep it to simple atomic values, then you can do a lot of complex analysis, and it takes you a very long way. Resist the urge to build really complex nested data structures, because when you start thinking, they say, well, actually, this is related to this, and this is related to this, and you can go down this hole of like having a very complex analytics data structure that's then very unwieldy to manipulate later. So keep it simple, just numbers and counters, low-hanging fruit, right? And then with any data that you're collecting, just always tag it with a couple pieces of information. Always the user that's doing it, always the action, they're logging in, they're logging out, et cetera. A session, which is going to be context dependent. It could be a session ID. If it's something on a general screen, for example, it might just be their session ID for that whole long session they're logged in. If they're in a specific level and you want to track it down to the granularity, hey, while they're in this level, what are the different things that they did, then you could give them a unique ID for that level. And then finally, the timestamp. ISO 8601 is just a common date format. There's conversion functions in every single language and framework imaginable. Just do it in that common format, because you can just slurp it into any number of tools. They all recognize that format. So that's in a nutshell like what we want to collect, right? We want to define the events that are important in our game, key different decision points, key different points in our workflow. We're going to figure out what metrics to measure. Keep it simple, low-hanging fruit. And then you're always tagging it with who's doing it and when they're doing it. And if you can do that, then you will be much more successful than people that are not instrumenting their games. This is fairly straightforward. It might take you a day or two to just kind of iron it out, put some simple analytics code in your game. Again, we'll talk about our analytics SDK as one approach to doing that. But you'll be miles ahead of people that are not taking these steps. So when you're first integrating analytics, what a lot of people do is they end up using an off-the-shelf analytics tool. There's a lot of great tools out there, so this is not intended to say that those tools are bad. There's tools like Flurry, Localytics, et cetera. Great tools, probably many of you have used those. They're very easy to integrate. They give you pre-baked reports where you can just see, hey, number of users playing, et cetera. What people find is at a certain level, you do kind of wind up hitting limits with rate limits. It's one thing to send a few hundred or few thousand metrics. If you're a very successful game and you're trying to send tens of thousands of metrics, people can run into issues with that. Retention windows for how long it's going to stay in the system. And then ultimately, your data is kind of stuck in somebody else's system. So what I would say is if you're going to use one of these off-the-shelf tools, which again, the intent here is not to spread FUD and say, ooh, watch out, these tools are bad. But to say if you're going to use one of these off-the-shelf tools, keep these decision points in the back of your mind. Check out whether or not they have just like a data export API. Check just what, if they have documentation on the kind of limits, And if they, hey, contact us for more info, send them an email and say, hey, what kind of throughput can we expect, et cetera, just to kind of get edge guidance for what you can expect out of the system. The good news is more and more of them are realizing these are points of contention, so they are providing stuff like export APIs. So as we go through this, even if you do start out down that road and you decide you want to do this complex analysis, I'll outline some ways that you can export your stuff out later. So OK, with apologies to the gnomes, a real business plan here. So these are, when you talk about analytics, and this is not just game specific, but you talk about big data analytics, et cetera, these are kind of 4 big steps. There's some variants of this, but these are your kind of 4 big concepts. You've got your ingest, which is how do you actually get the data in. You've got your storage step, which is where do you actually put it. Process, which is processing you need to do, either data munging or running equations, et cetera. And then the analysis step. And that's where you're actually both using a tool but also making that mental decision, like what are you going to actually do with this data? So how does this break down in terms of different offerings that are out there? So you've probably heard a lot of this. This is a very fast-moving space. If you've done some reading on data analytics, you've probably seen just a whole bunch of what seem like buzzwords. But the fact is that there is just a ton of work being done and some really interesting developments right now. So I'll just highlight a few of them, the kind of key ones. For ingest, in the simplest situation, you can actually just do an HTTP put up to something like an S3 bucket. I'm going to talk about that, similar to what we talked about in the first part of the talk when we were talking about, hey, how do you upload user-generated content? You can upload analytics in the same way, right? You can just upload your analytics data. As you get more sophisticated, you've got solutions like Kafka and Kinesis and Scribe, which are these kind of real-time fabrics where you can actually have all these readers and writers. I'll cover that at the end of the talk, but the idea is that you can be as simple or as fancy as you kind of want to be at the ingest, and the more and more complex you get, the more real-time you get, but there's, of course, more complexity in those solutions. Storage, in the simplest situation, S3, DynamoDB, we talked about that. That's a good storage option as well. If you're using a MapReduce parallel product, and don't worry if this is like a lot of stuff all at once, don't worry, it'll start clicking in. HDFS is the underlying system for shared disk for stuff like Hadoop, big data analytics. And then Redshift, which is our data warehouse. And I'll go through each of these, so don't worry if they're coming by fast. And then for processing, very interesting development. So a few years ago, if you want to do big data parallel analytics, basically your only option out there that was widely used was Hadoop. Essentially what Hadoop is it's a big parallelized framework that is designed to run on a whole bunch of cheap commodity hardware. And it's got a lot of benefits to it. It's great in terms of the fact that it can just reach very large scale, but it's not the fastest thing in the world. And so there's been new, more recent stuff that's been released, like Spark, which is an in-memory variant, as well as Storm, which does streaming. I'll talk about later. And the idea being for very large data sets, there's some certain advantages to going with one of the newer solutions. And then finally, analyze. This is kind of a list of GUI tools. Tableau is very widely used in gaming, perhaps the most widely used. Pentaho is an open source variant that's quite good as well, and Jaspersoft and some others. And all of these can actually interact with the tool sets that we'll be going through. So that's on the kind of GUI visualization when you're looking at the data and trying to make heads and tails out of it. So as I mentioned at the very start, like I'm a big fan of starting simple and iterating. So in the very simple, just how do you get some data about your game? So just write an events file on the device, right? It just has your your timestamp, log in, session ID, and just, hey, what's going on? Hey, they logged in, they started a game, they end a game, okay, and then later on they logged in again, they got a list of friends, they started a game, etc. And so keep that spooling in the local save on the device, whether or not it's a mobile device, whether or not it's console, etc. There's always a local save area. Just spool that out, and periodically just do an HTTP put to S3. Just wrap that up and just put the file up there. This is a CSV format. You can use JSON instead if you want. CSV is nice because there's a lot more things still that parse CSV natively. Upload that to S3, and you can just keep sticking data in S3. And that's the main thing. Is even if you don't have time to actually worry about it at the start, you're too busy getting the game out, which absolutely happens, just stuff data on S3 and come back to it later. But the key point here is collect data from day one. Like from the very first download, you need to have data about your game. Otherwise, you really are flying blind. You're not going to know why people are downloading it, why they're coming into game, why they're leaving, etc. And once it's in S3, you have a lot of different processing options. S3 is kind of our fire hose, our nexus, if you will, in the AWS land. But even outside of AWS tools, we natively offer lots and lots of other tool sets out there, freeware, open source products, et cetera, are designed to work with S3. So it's just a great landing place for all your data. So Redshift is our data warehouse as a service. I'll talk about it a little bit more in depth. But like our other services, you can spin it up, spin it down. You pay for how much you use. So you can spin up a Redshift data warehouse cluster for a few hours, do some analysis, spin it back down. Redshift's a SQL compliant offering. So the nice thing about that is you can take Tableau, you can point it to Redshift, do familiar SQL queries like you would on MySQL or SQL Server database running locally, and the tool will just work as expected. So I want to pause here. Some of the later examples I have get really pretty complicated. There's some cool stuff you can do with them, but they really kind of wind off on the weeds. This is absolutely a great solution for 80% of game analytics. Like if you only have time to do one thing, like just do this, and you'll be miles ahead of most of the other game developers out there. So I can't emphasize that enough. Don't feel as we go through this presentation, and we wind up at the end and we start talking about real-time analytics and all this other kind of stuff, that you have to do that in order to be successful. That's not true. If you look at game developers as a whole, and I include myself in this because I've been in the game industry, as I mentioned at the start, is that we're all like years behind what the people in the web side of things are doing. If you look at what people like the Twitters and Facebooks and Googles of the world, they're like a decade ahead of us, and we're just catching up. So just start. Don't realize you have to shoot the moon right at the very start. Like, let's just start simple, get some data from your game, do some basic analysis, figure out why people are playing the game, and then iterate, and then do more interesting analysis after that. And of course, this profit. Great, end of presentation. Thank you very much. Anyway, so a little more detail on Redshift, what this is. And don't worry about all the details here. You can read it on our website. But it is a managed data warehouse as a service. What you can think of it like is you can think of it if you think of like the traditional warehouse, if you've ever heard of Teradata solutions, et cetera, on-premise. It can get very costly, very large boxes, et cetera. This is the same kind of concept by the hour. You have a leader node, which actually takes care of ingesting the data and coordinating all the querying. As I said, it's completely SQL compliant. To you, it just looks like a SQL endpoint. You just have a SQL ODB string that you can just put into whatever tool you want. You can run familiar SQL queries. On our end, under the hood, it actually uses the leader node to coordinate that. And then you can have n number of compute nodes. Again, as you scale up, you can just keep adding compute nodes, grow your data as much as you need to. It's got built-in adapters, as I mentioned, for S3. Also has a built-in adapter for Dynamo. I'll highlight both of those. And then there's also just a single node, which is if you want to just run just one node, just to be as cost efficient as possible, you can spin up just a leader node and do it all in that one box. And to get started, that's a great way to just kick the tires. If your data set is of any reasonable size, a few tens of gigabytes or even a little bit bigger, you're not going to have any problem with just running a single node. We have customers that are using hundreds of terabytes, like very large Redshift clusters, and you can just kind of grow and grow and grow as your data set continues to grow. And as I mentioned, Tableau, very popular. This is actually from Tableau's website. I wanted to give you a concrete example. So on the left side, don't worry if you can't read it. You can easily find this. If you just search for Tableau Redshift, it pops right up. And this is an example of just how they actually interface Tableau with Redshift. On the left side, they just enter it just like a standard SQL database. And then the right side is actually a demo that they have of somebody actually dragging and dropping and pulling data out of Redshift. Point being, just all your familiar tools work. So what's the nitty-gritty plumbing of this solution? And again, I'm spending more time on the solution than some of the later ones because of the fact that I really want to drive home. It's pretty straightforward to set up, and it gives you a lot of bang for buck. First thing, you create an S3 bucket. S3 is our HTTP-based file store that I mentioned in the first talk about actually AWS architectures. But you just create another S3 bucket that you're just going to land all your event data in it, call it your game and analytics or something like that. Set up a security token. That's, again, on our website. These links will be available on the web, so you'll be able to click on that. That's just documentation for how to set up a security token, so that way your mobile device can actually just upload data to S3. Upload the data, as I mentioned. You're going to run this copy then. Again, each of these is actually just a couple steps, and I think I have a copy slide next. Each of these is just a couple steps, so a couple steps to set up a security token, a couple steps to actually set up this copy job from Redshift. Tableau to access Redshift, that's a link to that article I just described, and then you can go to the beach. And you can relax, and you can see what your users are interested while you're enjoying the sunshine. This is actually an allusion to an inside joke from years ago when we always used to comment the fact that in the console spaces, those of you who've been around for a while know it was all box product based, and you would ship the product, and then everybody would go home and take a couple weeks off, and now shipping the product is just the start of the actual cycle, right? So it's a very different mindset these days. All right, so how do you actually load Redshift from S3? Just a couple more slides. This is the whole command you use. That literally is it, minus obviously you've got to specify your access key. You can see you just copy from the S3 bucket you set in, copies the events that you created. It will stick it in a Redshift table called events. From there, you can do a SQL query based on it. It really is that simple. There's the delimiter at the end. You could use pipe delimiting or something else instead. And this link to this article is actually an article that another solution architect wrote where it actually talks about how to just set up a nightly job to do this. We have one of our services is Data Pipeline, which you can run scheduled jobs. I'm not going to spend any time on it, but if you look at that article, straightforward, it just says, click this, set up a data pipeline, use this script, set your access keys, and then you can actually set it up so on a nightly basis, it just pulls the latest data from your S3 bucket and puts it into Redshift. Again, real easy way. I'm not trying to trivialize it, but it really is this simple to get started. So you've got that basic foundation. What? More data, right? More data is better. So another easy thing to do is also collect your server logs. They're already there, right? You're already, if you're using Apache Nginx, whatever, even your own game servers, you're already logging a ton of data. There's no reason to write additional logic. Just collect that data. The Apache logs or Nginx, they have great wealth of data. Which IP, so you can map it to geos. What API endpoints are they hitting on your system? You can see what's the most popular. There's just a ton of data in there. Just zip it up and put it on S3. Simple scripts to do that, and just stuff that into the Redshift via the same process. And you can do this with external analytics data too. So I mentioned at the start, okay, if you want to use Flurry to get started or Localytics or something like that, again, nothing against those tools. If you reach a point where you want to do deeper analytics than those tools provide, use their export API and just dump it in that same S3 bucket. And then you can pull it into the same workflow. Right? The building blocks are there. I really do want to emphasize this is the cool part about AWS to me, that I think we do a good job at is, and one of the reasons I started using it is I was a client before being on this side. Anyway, is that you can just put together these pieces very simply. Like we eat our own dog food. Like if we actually want to make use of services between our services, we don't build secret backdoors and hook them together in secret ways. We use the same API endpoints that other people do. So all the kind of stuff that you could do in terms of loading Redshift, you can pull an external data source, put it in, stuff it into Redshift, same idea. And this is a quick example I won't dwell on, but highlighting just how simple it is. This is using Logrotate, which is a very popular Linux tool. A couple lines of this, and there's articles at the end there that you can actually read about, and it goes through the steps in detail. But it's just a couple lines that says, hey, grab the log files, send them to S3, restart Apache. And at the very end, I just want to highlight that we actually now, ELB, our Elastic Load Balancer, which I talked about at the start, we now provide access logs from that as well. You can use the same kind of process. You can set those up to dump to S3. Again, just use S3 as your holding area and just dump all your data there and then sift through it later. I mean, really, just dump. I mean, you can stuff as much data as you want in S3. You pay just for how much data that you store. It's, in the US, it's 8 cents per gig per month. So you just, I mean, if you do the math, you can store a lot of data there for, $80, $100 a month. Just stuff a whole bunch of data in there and figure out what to do with it later. So with this stuffing data approach, there's a little caveat, and that is how do you deal with messy data, meaning there's a lot of data in different formats. Right, you've got whatever device, CSV, JSON, whatever you're writing out. You've got Apache logs, which you don't have any control over there in whatever format. If you're using CDN via CloudFront or some other CDN, it's got those formatted logs. You don't really have any control over that. So one very popular tool that we find used here a lot is Elastic MapReduce. I really quickly skimmed over this at the start. I'm going to talk about it in a little more detail in a minute. That's our managed Hadoop offering. And what that does is it lets you run arbitrary, say, Java, Python, et cetera, code. And it'll do it in parallel. And you can either set it up just to spin up and do something and then spin back down, or you can set it in the background. So it's just constantly going through new files that are uploaded to S3, cleaning them up, manipulating them, normalizing, sticking them all in the same format, so that then when you actually load it into Redshift, Redshift can just bring all the data in because it's all in a similar format. Redshift, I'll go through the comparison. Redshift, because it's a standard database, you need to predefine your database schemas. It's got a bunch of optimization technology, which we'll talk about, but it's at the heart, it's kind of a standard database idea where you have columns and you have rows. So you need to predefine that. So if you have this data flowing in all these different formats, and some of it has stuff in different parts of the file, et cetera, then you need to normalize it down to one format. So Elastic MapReduce, which is our managed Hadoop, is very popular for this. You could also just run a Ruby script or a Python script or shell script from the command line using data pipeline. That same article I showed, which was using data pipeline to run this periodic copy into Redshift job. If you read through that article, that same approach, it's just a shell script that it runs that just runs the copy command. You could just as easily have a shell script that just says, hey, find the files between these two dates and scrub them out and spit them out into a new S3 bucket or something like that. So straightforward approach. Hopefully that's making sense so far. Stick all your data in S3. You have a little bit of a cleanup step, and then just land it all in Redshift, and you can use the familiar tools that you're used to in order to do analysis. I already talked about that, outputting the clean bucket and then loading through the same process. So I want to spend a minute comparing and contrasting these because it's not obvious which one makes the most sense in different situations. So Elastic MapReduce, as I mentioned, was the first thing that came out several years ago, well, more than several now. And it rose out of work that Google, among others, had done in order to do a very large amount of parallelism over very large data sets. So the nice thing about MapReduce is it can scale out, out and in based on the number of EC2 instances you're using, and that's how it's all implemented. It just runs on top of EC2 instances, but you can't use your familiar tools. And that's why we released Redshift. Redshift it's a columnar database, so it's familiar database concepts. But rather than the data being stored as rows, it's actually stored as columns. And that distinction just means that it makes it much quicker to do any kind of calculations that go across data. Anything that goes down a column, like, hey, give me the average playtime across all 10 million records that you have over the past 3 months. Boop, it spins that right up. If you actually want to try to get an individual record, it actually takes quite a bit longer because you can just think of the data as kind of being shifted 90 degrees. So it's optimized for any of those kinds of aggregations or any kind of those big calculations you want to do across data sets. As I mentioned, Elastic MapReduce is Hadoop, which is just a very different concept. If you've never looked at MapReduce code, essentially you have 2 passes where you go by and you kind of do this mapping, this kind of distilling down, and then the reduction stage. It's very mathematical, and it's just a different way to think about data. It's hard for me to describe in one sentence, to be honest. So in Redshift, you have a familiar SQL options, all the operations you're used to, Tableau, et cetera. I already highlighted that. HivePig was released to actually address the problems that people have interfacing with native MapReduce. It's kind of a layer that sits on top of MapReduce. It's kind of like an interpretation language almost, if you will. Pig's very widely used by Twitter, for example. So that can close that gap quite a bit, but it's still not the same as having a native ANSI SQL database. Redshift is best, as I mentioned, for structured data. You have to have it in something that looks like a columnar format, whereas MapReduce really shines in stuff that's just all over the map. So that's why when you look at that actual example that I showed you where I showed, hey, how to use MapReduce to actually clean data and then stick it in a normalized format, that's where MapReduce really shines, is it can just take data in any format. You can write any kind of arbitrary code you want, restructure it. It's at a different level of granularity as opposed to Redshift, which is based around SQL tools. A few more differences. Redshift's based around a load then use, like you have to load, and then you actually use the data. You load, and then you use the data. Whereas one thing that's, faster to query, these are a little bit out of order. Whereas one thing that's interesting about MapReduce is some of the newer options is you can actually do this constantly streaming loop. We'll talk about that a little bit. And Redshift is faster to query, as I mentioned. It's hyper-optimized for all those cases that, common running aggregation across very large data sets. MapReduce really shines the fact that you can just have just enormous data sets like you would get out of any kind of these big data. If you think of the amount of data somebody like Twitter has to chew through, EMR can just continue scaling up to those very high levels. And the last thing I'll highlight is Redshift is built with long-term storage. You can put your data in there. It's going to be persistent. We're going to take care of that, backups, et cetera, for you. EMR out of the box, Hadoop is really transient. There's no built-in snapshotting. It's just not designed to be that. It's really designed to be more of a data munging and processing engine more than a data warehousing where you're putting your data for it to stay. So going back to our example for a second, I want to take a quick side note here. So earlier on in the talk, the very first talk I gave was about integrating your game with Elastic Beanstalk. So you have, assuming that you agreed with my advice and went and used DynamoDB, there's actually adapters for DynamoDB to load directly into Redshift as well. So that's another example of a good data source. The other kind of interesting thing is that Redshift does do is this kind of intelligent merge. So even though you do have to have your data in a CSV or something pipe delimited format, Redshift will actually, when interacting with stuff like Dynamo, for example, will actually resolve it and say, OK, well, this column is missing, so set it to null. And these other columns I don't recognize in the source data, so just ignore those. So there's a little bit of leeway you get from Redshift out of the box, which is nice. So you can send your data directly to Redshift from Dynamo. Maybe you have your games tables or your session tables or stuff like that you already have it in Dynamo in your game DB. You might as well just send that directly to Redshift. As I mentioned, it'll track those keys and columns and resolve those differences. And the other cool thing you can do is you can actually stream from Dynamo into Elastic MapReduce. I don't want to focus on that just yet. I'll come back to that. But the highlighting point that I just want to make is you've got two different options here. And we'll see that as we get a little more into the weeds. You've got your load then query option where you're sending data to rest and do long-term queries. And then you've got this kind of streaming, this real time, for lack of a better term. We'll come back to that. Now here's an example of loading Redshift from Dynamo. You'll see it's very similar to the other example of loading via S3. This is just copying a table from Dynamo rather than copying from an S3 bucket. And there's no reason you couldn't all just put this into one script that was run from data pipeline, right? Hey, copy over this data from Dynamo, copy over this data from S3. And that could literally be, maybe you need a couple more lines, but that could literally be your actual nightly loading script. So hopefully, I've impressed on you that this stuff is pretty straightforward to set up. It's not 20 minutes of work, but it's not 6 weeks of work either. Maybe take a couple days to wrap your head around it and kind of get how everything works together. But it's easy to kick the tires. Again, you only pay for what you use. We have free tiers available for many of these services. Play around with it. See how the different pieces can be connected together. There's actually a lot of pretty powerful stuff you can do with just connecting 2 or 3 of these things together. All right, so you've got all your data. Awesome, cool, now what? So that doesn't actually do anything quite yet, right? We've got all this data collected, we've got it all organized, but we actually have to do something for our game. So I'm sure everybody has seen some kind of retention funnel. So this is a way to kind of think about your data, right? You've got some kind of acquisition. You're either doing a promotion out there, you're maybe even spending money on advertising, Google AdWords, whatever, and you're trying to get the word out about your game. And then as you kind of go down the funnel, more and more people, it gets skinnier and skinnier, you get less and less people, right? You get into retention, you say, okay, well, this is the number of people actually after they downloaded and played the game, they stuck around. And then out of those people, then these people actually spent money. And then eventually at the bottom, the red arrows, okay, people actually leave the game. And then hopefully, and I think John and Mike are going to talk about this next, hopefully you're able to either via mobile push or something else get them back into the game, re-engage them. And you could potentially make more money. But eventually, everybody's going to leave your game at some point, if nothing else at the heat death of the universe. But the point being is people will leave your game eventually. So the trick is how do you widen that funnel as much as possible and kind of keep it wide? The narrower it gets, the sooner, then that's less money you're making, right? The narrower it gets, more people are dropping off at early stages. More people are like, I downloaded, I played it for 20 minutes, I don't get it, et cetera. So let's go back to the kind of basics, like starting point. Again, this is just, all the other stuff I added on is interesting stuff and more advanced stuff, but let's just go back just to starting with this. You just got your device statistics, you're sticking them in S3, you're doing your analysis in Redshift. So what's a first pass thing you can do? Well, a first pass thing you can do, and I have this in SQL only for the point of illustrating that Redshift is just a standard SQL structure. You can do this visually in a Tableau, for example, or Pentaho. You can drag and drop this as well. So don't think you have to become a SQL expert. The only reason I wrote the SQL up here was just to illustrate that any of the familiar SQL stuff, if you are a SQL whiz and you know group by and inner join, et cetera, you can do all that kind of stuff with Redshift. What this does, in a nutshell, is it just creates a view that says, hey, here's the events that were recorded for a given user for a given month. And the rest of it, just that total events down there, that's just the number. Like they did this number of events on a given month. What's that's going to let us do is it's going to let us, as a very simple first pass, measure retention. We'll be able to say, okay, this guy didn't exist, and then he played 20 times, 10 times, 5 times, and then they fell off the map. So he was active for 3 months. Okay? So what does that look like? So if you run that exact query, here's what it gives you. And it's better than nothing, but not much. And the reason why is there's just so much noise in the data because each of the sequences is starting at different times, right? The first guy is starting in November, and then the next guy didn't start playing until February. And so you can squint a little bit and see, okay, well, it kind of looks like people play a bit, and then they go down, they come back a bit, but it's really hard. Like, you kind of have to do a lot of mental math, and this was only with 4 people. You can imagine if you had a few thousand people, like this it would just be a solid blur of color, right? So what do you have to actually do? You have to figure out a way to normalize this data by time. Remember, I mentioned that time is very important. If it's 2 weeks, 3 weeks, et cetera, it's one of the key axes of your data. So there's a widely used approach that's very popular in medical circles, and it's called cohort analysis. And all that fancy term means is you group your users together by some kind of common attribute. And one easy way to group them together is by time. In this case, for example, we could group them together by the first time they played. And then what that would do is that would give us then, going back to what I was saying at the very start, where deltas being more important than absolutes, right? If you do it relative to the first time they've played, then everything else is a relative percentage. And it says, okay, rather than it being all over the map, it says, okay, for a given user, week 1, week 2, week 3, here's what they're doing. So you do the analysis based on that cohort, which is just that group of users by time. And you can change your cohort around by query. Right? You can change multiple cohorts. They're ultimately just database views. I'll show you an example. And you can pivot them around. You can say, OK, for this query, what's most interesting is the time that they joined. For this query, what's most interesting is the maximum level they've achieved. Maybe you want to measure difficulty, for example. And this is a great example of using Redshift in this case because it's just SQL, and all these operations are very well mapped to SQL. So there's a link at the bottom. That's actually a great blog that goes into cohort analysis a little bit more in depth, actually with Redshift. Again, we'll post these slides. I would encourage you to read these. Again, this is the SQL. A lot of these tools, Tableau, Pentaho, et cetera, you can drag and drop this. But I just thought it was interesting to kind of outline the fact that you can run these queries natively, which is something you can't always do with a third-party tool set. If you wind up with your tool on somebody else's servers, a lot of times they will give you an interface, web-based, et cetera, to actually interface with that. And you want to go down to that next level, and you can't get to that level. And the nice thing about Redshift is you have that level. You can go down there at any time. You can use the GUI tool. If you say, you know what, there's just the drag and drop's not working for me, I can drop down and I can get to that SQL natively. So what this does is this actually creates a cohort, a group of people, based on the first time they did something in game. And that's what midway down you see as first month, grouped by user ID. So it's going to basically create a structure. So OK, for this user, his first month was this. For this user, his first month was that. And if you think about your example event stream, I think I might have skipped a slide. Example, nah, unfortunately. OK, this is a little bit out of order, but I'll do it this way anyway. So this was our example games stream. So I highlighted specific events. So another option that you can use in addition to basing it based on the first time that they played, you can do it the first time they did a certain event. So in this example, you can say, OK, the first time they actually played a game, I don't care if they downloaded and logged in and looked at the leaderboard and et cetera, but I want to measure from the first time they actually played a game because that's what's actually most important, and then do the analysis based off that. So this is the same cohort description. The only difference is right into that first month. You can see that says where action equals game start. Again, hopefully it's kind of looking that it's simple to kind of build these things up. You can just add additional criteria. And so after you defined your cohort, step 2, and there's only 3 steps. Step 2 is to actually define the metric you want to measure. So this is the same thing I showed you previously. This is the events by user by month. This is just the same thing we already saw. The first SQL slide, I just wanted to rehash it. So you've got your cohort. You've got what you're going to measure. You'll notice they're both grouped by user ID so that you can correlate the two. And then you can do this kind of analysis. And now this is far more interesting, because now what we can see is we can say, OK, relative to the first time a person played the game or joined, whatever we're going to do, this is their play pattern. So on the right side, you can see all the different sequences. Those are people that started in November, started in December, started in January, February, et cetera. And then all the different lines say relative to that start date, week 1, 2, 3, 4. Here's the actual pattern that they followed. So we see, hey, week 1, they get it, and they start getting interested, and they play a little on week 2, and then they go down, and then there's a little bit bump, and then they go off, and they fall off the map. So pause here for just a second. So this, again, is one of those things that's so much more informative to us than if we didn't have anything in the game. And again, a lot of the tools out there that I've already mentioned, they can do this all in a drag and drop fashion, so don't get too caught up on kind of the SQL complexity. I just wanted to illustrate a point. But you can definitely do this in drag and drop, creating stuff on the fly. This gives you a lot of insight into your players already. You know that by and large, your players only play for 7 weeks. And the interesting thing about this is now you can say, OK, well, now I can take that information and then correlate that with some of the other information, maybe on the time between level progression, and see, OK, well, what's happening around week 7? If I'm charting out where these people are actually going along the axis, and they get to week 7, and then they stop playing, and hey, most of them are on level 9, for example. Just thinking a hypothetical example. Then you can start saying, well, there's something about that level that I need to drill into. Maybe it's not in difficulty. Maybe it's not even a piece of metric you're collecting yet. But then you can target that metric and say, hey, I want to collect everything about levels. I want to dig into where people are dying. I want to dig into what items they're using, what characters they're playing out, et cetera. And again, it goes back to that whole virtuous circle. The more of this data that you're collecting, the more of these questions it's going to cause you to ask. And the great thing about that is the more questions you're asking, then you can distill it down and say, OK, what are the things I collect? So I want to find out, why are people leaving after week 7? I can look at where they're at the game. I can look at their purchase history. I can look at their maximum level they reached. I can look at their place on the leaderboard. And it gives you a very interesting way to actually correlate that data together. Excuse me. So a few more examples here. Quick just diatribe or tangent. So I mentioned that companies like Rovio are very, very successful at targeting their players, Supercell, et cetera. They have this kind of analysis, and they have many other forms of analysis. And we're just kind of at the tip of the iceberg as game developers, where we're just kind of doing that first pass. This analysis is not hard. It may look a little bit tricky if this is the first time you've seen it, but it's actually not really that hard. You could read up on it in an hour or two, look at the way Tableau or Pentaho supports it, and I'm confident with the level of skill in the game industry that most of you would be able to knock it out really quickly. So it gives you a really interesting, fascinating set of data. In my opinion, there's just an amazing amount of opportunity still in this space to capitalize on. And I want to pick one example that everybody should know and love. It's Candy Crush. So by any possible measure you can think of, is an incredibly successful game, right? Nobody's going to argue with that. And that's one of the reasons why I chose it, is because it is a popular and successful game. Because this is not meant to say that, oh, Candy Crush is bad or anything like that. But I just want to illustrate a couple things that I think, if you had this data about your users, and you knew what they were doing and what they were interested in, and you knew which kind of items excited them, right? Think about the kind of interesting stuff you could do. Like, when you come to one of these levels and you say, OK, maybe I'll get a power-up, and you get this. In my opinion, this is just such a 1.0. It's just, there's so much missed opportunity. This says, OK, you can buy 3 of these for $199. Why? Like, do other people have luck with this? Like, do my friends buy this? Like, is this something that if I buy this, what percentage chance is it going to give me better? Am I getting a 50% better chance? Like, or is this just going to be a waste of money? So there's so much stuff you can do if you start instrumenting your users. not only is it just interesting information, but you can actually start putting stuff like that in the game. Imagine if you could have that data feed and you could actually have this pop up and say, hey, 80% of the users get through this level if they buy this power-up. Now that's a far more compelling purchase. Now I'm like, okay, well, hey, you know, I've been playing this for a week. Maybe I'll buy that one, right? And same thing at game end, right? Another great example. They say, okay, do you want to keep playing? You know, yes or no? And there's just nothing targeted to me. There's nothing that says, hey, you tried this power up. How about another one for half price? Or hey, how about, you know, since you've been, you know, so loyal and since you've played this level 20 times, we'll give you a bonus. We'll give you a 50% discount on the actual continuation. There's just a lot of stuff here. Obviously, these guys are wildly successful, so I'm not trying to bag on them in any way. But I'm just saying, even with how successful they are, there's so much more stuff you can do in this space. There's so much more low-hanging fruit that all of us can take advantage of. So along those lines, I want to talk about, this is the last big topic I'm going to cover. And I want to talk about real-time data. And I just want to emphasize here when we talk about real-time data, talk about what's interesting about it and strategies to do it and kind of the future as I see it. But don't get hung up. Don't think you have to do this in order to be successful. From real-time data analysis, there is a fraction of people that are doing this right now, a fraction of people in the gaming space. So it's untapped potential, uncharted territory in a way. So this is kind of stuff, just get your wheels moving, start thinking about, hey, what could your future game look like? Maybe not this game you're working on right now, but like, you know, really kind of think big type stuff, for lack of a better term. So Firefall is a large world, open world MMO that runs entirely on AWS. It actually uses you know, a variety of different services I highlighted in the first talk. These were the guys that are a bunch of ex-Blizzard folks, and then they went over and founded Red 5 Studios. So it's a very large MMO. It's got a very gigantic, you know, world with lots of streaming data going between different shards that are all managing the actual universe. So it's actually a really interesting architecture. And one of the common things that you see in this space is heat maps, right? Well, like there's post-match heat maps, and that's interesting. It's cool to put on a website, and it's also cool just for analysis, shows you where everybody died. This is an example I took from Unity's website, for example. Unity's got some good out-of-the-box stuff that you can use, at least in local development mode. So it's cool, and a lot of people are doing this, but that doesn't actually let you change the game, right? It doesn't let you change the game or dynamically do anything in-game. It's good you can change your next game on it, or maybe change your DLC pack that's coming out 3 months ago. But what if your world is changing in real time? So I don't know, did any of you guys see the massive EVE Online battle that happened a little while back? Did you guys hear about this? So there was this gigantic, you know, EVE Online, we're all familiar with it, is gigantic open world MMO game. And essentially there was this massive battle between two of the main clans that cost something like $500,000 in real money once they calculated out the number of ships that had been lost. And it was like this multi-day battle. And the only reason why anybody knew about it was because people started posting and started talking about it was going to go down and they were going to do it at a certain time and stuff like that. But imagine if they had that instrumented. And CCP is a great game company. I choose them because they're wildly successful, and so this is not taking anything away from them. But think about if CCP had this real-time analytics system, you know, that was able to actually change the world on demand and be able to see what was happening, be able to feed stuff through and change stuff, and be able to, from a monetization standpoint, be able to target certain users and be able to say, hey, you guys are in this massive battle. How about, you know, discount on ship supplies, discount on ammo, discount on shields, et cetera. You get the point. So there's just a ton of untapped potential, not only for making an interesting game, but just from a revenue perspective. So we talk about real-time analytics, and we talk about batch that we've talked so far. So that's like what game modes do people like best. That helps us make decisions maybe about the next update. Real-time tells us, hey, what are they actually playing in now? Batch says, hey, how many people have downloaded a certain map pack? Real-time says, are more or less people downloading that DLC today? Batch tells us, where do most people die on a given map? Real-time says, are people dying in different places, right? And the last one is how many daily players are on average? And everybody is familiar with the sine wave curve, where you kind of have an average user players. But how many people are playing today? So going all the way back, bringing it full circle, right? Like, wouldn't it be great to know something like this in real time? Wouldn't it be great to know, rather than seeing, okay, your server's scaled up, wouldn't it be great to have analytics about what your actual users are doing to drive that? Wouldn't it be able to actually turn that into a monetization strategy? So we'll talk about that. So there's two big tools. We've got about 10 more minutes here, and then I'll wrap up. So two big tool sets here in this space. Spark on the left side, as I mentioned Hadoop earlier, That's the MapReduce framework that's designed to scale horizontally. Spark is actually a new project from actually a researcher, super smart guy, Matei at Berkeley. And he actually now is the CTO of a company, Databricks. What it is essentially it's a new take on MapReduce, on Hadoop, if you will. It runs in memory. It's got compatibility with HiveQL, their SQL layer. And in some of the benchmarks people have run, it's 100 times faster than Hadoop. And if you think about that, that's anything that's 100 times faster than anything else, that opens up a whole new world of possibilities, right? And it can run on EMR. I've got a link where we've actually, another one of our solution architects who's a super whiz at all things Elastic MapReduce, I got a link to his article where he shows you it's a couple of simple bootstrapping actions, and you can actually run this on Spark. And then on the right side is Kinesis. This is a recent service that we released. And you can kind of think of it as this data mesh. And the idea being is that, so Kafka, if you've ever heard of that, Kafka is a similar kind of concept. It's just this distributed data mesh with all these nodes that intercommunicate in order to let data flow through at a very high rate. Well, Kinesis is our managed version thereof. So when you're defining these, you define streams in Kinesis. Each of those streams has shards, and then each shard can ingest a certain amount of data. And the last little point I'll point out, and you can read all the specifics about it again on our website, but it stores your data for 24 hours, which is interesting because you can replay data. But it's also, similarly, it's not designed as a long-term store. And I'll highlight a couple things there. So again, back to basics. By definition, this is always going to be batch. There's no way you can do streaming, right? S3 is a bucket. It's a batch bucket. There's no way to turn that into something streaming. So what do you do if you want the data to flow through as quickly as possible? Well, that's where Kinesis comes in. You swap out your S3 layer for Kinesis. Again, similar HTTP API, so it's easy to make that transition. And the idea behind Kinesis is, again, you can have all these readers and all these writers. You can still have your data flowing out to Redshift, so it doesn't invalidate all the tools that you've already written. You can still be running all of those nightly queries the same. But in addition, you can do some more interesting stuff on a real-time basis. Now you can make use of stuff like Spark or Hadoop, Elastic MapReduce, and be able to actually have that stream in just a few seconds. It's coming through there, and you can actually be making decisions in real time, feeding that into other systems, doing analysis in near real time. If you are familiar with Storm, which is an open source product, also very widely used, we have a spout, as Storm calls it, from Kinesis, which enables you to directly take data and plug it into Storm in real time. And then any kind of custom EC2 worker. So when you talk about heat maps, what about if you could generate a heat map in real time? You can actually trace users where they're running around, or you could have your EC2 code just ingesting that stream. So in addition to all the analytics you're doing, all the analysis you're doing, you can actually be doing additional data. So the idea being is, just kind of think of it as this mesh, this data mesh, where you're just kind of pushing all this data through, and you're having multiple different things read off at the same time. This is our Kinesis-based diagram. It just shows the same thing in a little different format. This is on our website. It's the same kind of thing on the left. You have all your different data sources. In the right, you have this Kinesis fabric. And then on the, in the middle, you have the Kinesis fabric. And then on the right side, you have all the different places that it can go out that we've already touched on. A few more details on Kinesis. This is the kind of multiple way mapping of producers and shards. We manage this for you, but it's just this is how it's kind of working under the hood. You have all these producers and all these shards. We use partition keys to actually map it across. I don't want to get too much on the details because when you read through the Kinesis docs, I don't want to lose the forest for the trees. And you can read more about this. But just the idea being is that we built it to be able to scale out as your data continues to scale out. And writing to a stream similar. At the very bottom, similar to writing to an S3 bucket, is just an HTTP call. It takes JSON. Hey, here's the name of the stream. Here's the value. Any other keys you want to store. So wrapping it all up, just a few more slides. So Kinesis plus Spark. And so I think if you look at all the different, if you think back to the slide I had where it showed you, all the different options, and it can get really confusing. Bang for buck, I think if you look at what you can do right now with Kinesis and Spark, it handles the vast majority of use cases. So you're using Kinesis as your way to stream data into the system. Again, the shard management is something that Kinesis offers. And then on the right side, you've got Spark launched via EMR. And that's actually ingesting the data in real time. And again, you can perform any kind of analytics stuff you'd want onto it, or send it off to Redshift, or you can perform real-time actions. You can say, hey, there's this massive battle going on based off the the data we're receiving from here, so we actually better need to start spinning up resources. There's some interesting orchestration you can do. And then you can also do, as I mentioned, perhaps from a monetization standpoint, the most interesting thing is that you can do targeted actions, and you can eventually, again, this is why I just think there's so much potential. Eventually, a couple years from now, I think it's going to be, if you want to talk about, what's the future of gaming, in my opinion, it's all going to be about data, and the faster you can get the data, then those games are going to make better decisions, and they're the ones that are going to kind of be the next gen top of the heap. And the reason why I think that is because the faster you can adjust, the faster that you can offer unique, inviting content to your users, then the more you can capitalize on them, the more you can monetize. And outside of just pure money, it keeps people engaged in the game, which is fun, right? Like, that's what we're trying to do. So wrapping up, how does this go back to our heat map example? Think about what you're doing when you're creating a heat map. You just have this constant stream that you can put into Kinesis. You say, hey, somebody died, somebody else died, et cetera. And then you can actually map it out in real time, where you could actually have little dots, and you could even animate this from either your social web portal or from actually in-game and show people actually running around spectator mode. And at least me, I think this is kind of like the ultimate end state, right? So hopefully that at least gives that endpoint, at least gives you some food for thought. Again, the streaming real-time data, we're just going down that journey. We have tools that I definitely think are worth at least playing around with, checking out, using our free tier. But at the very least, do that low-hanging fruit. Collect that data, stick it in an S3 bucket, load it into Redshift, point your tool at it, call it done. And even if you get started with an off-the-shelf analytics SDK, and we'll talk about ours, which is also a great option, even if you go down that route, you can always export that data, stick it into S3, rejoin that flow later. So, but the point is, the more data, the better, and the more you can think about the kind of stuff you want to record, the better position you're going to be in. And if not, there's always this. So, cool. So thanks a lot again. That's the email address. If you're a game developer, as you guys are, and you want to talk anything AWS, that goes to me and other people that are a member of my team. We've got a small team. We just focus with game developers worldwide, helping them make use of AWS in new and interesting ways. Send us an email. Glad to connect you, point you in the right direction, and then that's my Twitter handle. So thanks a lot. Cool.